question 15. The curve C has equation x plus y cubed equal to 3x squared minus 3y minus 2. And then find an expression for dy over dx in terms of x and y. Okay, so it's just implicit differentiation. So for the first term, x plus y cubed, we bring down the power and then minus 1 the power. And then because inside the brackets is x plus y, it's not just x cubed, it's x plus y cubed. So x plus y would be the chain. So it times by the derivative of the chain. X differentiate to 1 and then y differentiate to dy over dx. And then that's equal to 3x squared differentiate to 6x. And then minus 3 is a coefficient, doesn't change. And then y differentiate to dy over dx. And negative 2 is a constant. So differentiate to 0. And now we just have to rearrange it and make dy over dx as a subject. So expand the brackets. That would be 3x plus y squared. And then plus 3x plus y squared dy over dx. And that's equal to 6x minus 3 dy over dx. And I'm going to make all the dy over dx term to one side and then the other terms to the other side. So I will keep this one on the left and I move this one to the left-hand side as well. And I move this one to the right-hand side. So which means I will have 3x plus y squared dy over dx. This one I keep it here. And I plus 3 dy over dx for both sides. So then this term will move to the left. And then 6x stay the same. And I minus 3x plus y squared for both sides. So now I have all the dy over dx term on one side and all the other term on the other side. And now we have 2 dy over dx here. So to make it just one, we factorize out dy over dx because that's a common factor. So that would be 3x plus y squared plus 3 equal to 6x minus 3x plus y squared. So then dy over dx is just equal to 6x minus 3 times x plus y squared, and then divide by 3 times x plus y squared plus 3. And then all of them has common factor 3. So we can divide by 3 for both top and bottom to make it simpler. So 6 divided by 3 is 2, so 2x minus x plus y squared over, so this one divided by 3, just x plus y squared, and then 3 divided by 3 become 1. So that would be the final answer for part A, so 5 marks. And then part B, show that the normal to C at point P has equation y equal to negative 2x plus 2. And then point P is 1, 0. So substitute in, when x equal to 1, y equal to 0, then we will have dy over dx equal to 2 times 1 is 2 minus 1 plus 0 is 1, and 1 squared is also 1. So just 2 minus 1 on top. And then 1 plus 0 is also 1. Square that is 1, and then 1 plus 1 is 2. So just 1 over 2 left. So which means the gradient for the normal will be the negative reciprocal. So m is negative 2. So we have y equal to negative 2x plus c. So substitute in the coordinates when y equal to 0, x equal to 1. So 0 equal to negative 2 plus c. So c is equal to 2. So therefore, we have y equal to negative 2x plus 2. That's all. Okay, part B done. And then part C, so prove that the normal to C at point P does not meet C again. So basically, they just want us to solve the simultaneous equation for this line and the original one to see whether they only have one solution or not. And then that only solution should be point P. Okay, let's try to solve that. We have y equal to negative 2x plus 2. And then the other one is x plus y cubed equal to 3x squared minus 3y is 2. So if we substitute one to the other, that would be x, so plus y, and y is equal to negative 2x plus 2, and then cube equal to 3 times by x squared minus 3 times by y, which is negative 2x plus 2, and then minus 2. So 2, it doesn't change, it's just 2. X minus 2x, that would be negative x cubed, equal to 3x squared. Minus 3 times minus 2 is positive 6x. And then minus 3 times 2 is negative 6. And then minus 2 is just minus 2. So expand it out, that would be 2 cubed, which is 8. And then plus, so it's binary expansion. 1, 3, 3, 1. Yeah. So 2 cubed times by plus 3 times by 2 square times negative x. And then plus 3 times 2 times negative x square. And then plus 1 times by negative x cubed. And that's equal to 3x squared plus 6x minus 8. So simplify that, that would be 8 minus 3 times 4 is 12, so 8 minus 12x, and then plus 6x squared minus x cubed equal to 3x squared plus 6x minus 8. And then move areas into one side, so plus x cubed for both sides, we have x cubed on the left-hand side, on the right-hand side, and then minus 6x squared for both sides. So 3x squared minus 6x squared would be negative 3x squared. And then plus 12x for both sides. 6x plus 12x is positive 18x. And then minus 8 minus another 8 is minus 16. So that would be equal to 0. Okay. So this is a cubic. Like, we can't just put in the calculator and then say, oh, we only have one solution. We need to show it. And then we already know P is one of the points lie on both. So x equal to 1 is definitely one of the solution. So we already know x minus 1 will be a factor. We just have to find the other factor. So we can use London division to divide it. So x cubed minus 3x squared plus 18x minus 16 divided by x minus 1. So times by x squared to get x cubed and then minus x squared. So minus them, this will cancel out. Minus 3 minus negative 1, that'll be minus 3 plus 1, so negative 2x squared. And then bring down the other two terms. And then times by negative 2x, that'll be negative 2x squared. So negative 1 times negative 2x become positive 2x. And then minus, again, that'll be those two cancel out. That'll be 16x minus 16. So this time times by 16, we have 16x minus 16, which all cancel out, becomes 0. And then we can find our other factor, x squared minus ux plus 16. So now, if we want to solve that, we just let x minus 1 equal to 0, so x equal to 1, which is point P. And then the other one would be x squared minus 2x plus 16 equal to 0. So we know, like, this equation shouldn't have any solution because that's the whole point of the proof. We want to prove that the normal to C at P does not meet the curve again. So that means that's the only intersection point. So there should be only one solution. But you can't just say, okay, I've checked in the calculator, I have no solution. Yeah. So just normally we just use the discriminant to check how many solutions. So b squared minus 4ac would be negative 2 squared minus 4 times a times by 16. So that would be 4 minus 4 times 16, which is negative 60, which is less than 0. So that means no real roots. So therefore, point P is the only intersection point. And then we shoot it.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.